Hello friends, in today's video lecture of machine drawing, we'll focus on Cotter joint with sleeve. Okay, we'll focus on what is sleeve, we'll see what is a joint, what is the application point, how does it work. Okay, we'll try to discuss all of them. Fine. The arrangement, I'll roughly make an arrangement like how does it look like. Fine. Now in case of Cotter joint, the sleeve is nothing but a hollow, cylindrical hollow component. The component is something like this. Okay, we consider this as sleeve, which is having out and out dimension of 8d and internal diameter of, there will be an out and out diameter of 8d and an internal diameter of 2.5d. okay, internal diameter external diameter of 2.5d, internal of 1.3d. okay, the main concept or motto is to connect two circular rods. Okay, for example, if you have two metal sheets, if you have two different metal sheets, if you want to join them both, we have options. We have seen in our earlier lectures, like you can weld or else you can rivet, okay, to join these two. But whereas in case of circular rods, for example, this is circular shaft number 1, this is one more shaft number 2. In this case, how to circular shaft number 1, the load need to be transmitted or load need to be transmitted, or else torque, maybe it may transmit some load, some force, maybe not torque exactly. Okay, in this particular joint there won't be any rotation, the way we have seen in knuckle joint also. It is going to take only tensile forces, both the sides, tensile forces. It is not going to take any rotational force in this case also. Fine. So there is a joint called Cotter joint with sleeve, which will help you to join both the shafts to transmit load or forces. Okay. Now, for example, this is the required, these are the two required shafts of some diameter need to be joined, having some length, having a standard diameter and standard length, both are having same diameters and same lengths, need to be joined together. If that is the case, directly you can't join both the shafts. Okay, so what you need to do is, when you procure the raw material, you have to plan for a diameter more than the required diameter. Okay, if for example required diameter is 10, means you need to plan for 20 mm or else 25 mm. Okay, because after getting it to the shop floor, you need to design in such a way that, for example, the overall length is 50 mm. For example, overall length is 50 mm. After getting to the shop floor, what you need to do is, you have to plan your shaft, or the component shape should be something like this. This is 50 actual requirement, but wherever you are trying to meet them both to enhance the strength or stiffness of the material, to take the required load, what we try to do is, we will try to increase the diameter of the shaft. Actually, this size is actually not in our practice. This is not at all required. But still, we are increasing the diameter by 1.3 times. 1.3 times. That is the reason I said internal hole diameter is 1.3d. You have to plan for 1.3d. If your diameter is 10, you have to plan for internal diameter of 1.3d. So when you procure the raw material only, you have to plan for bigger diameter and bigger length. Once you get it to the shop floor, you have to design in this way. These two are not different, these two are integral. Okay, made from same piece of material. Okay, the other end also have same profile, that is seated inside the sleeve, and those two got joined, butted together, and from the top we will try to insert a cotter. Now the cotter dimensions are also standard. The height is 4d, having a width of 1.3d. okay, and there is a taper section of 1:100. This is a symbol for taper section. There is a taper section of 1:100. Means throughout the length there is a reduction of 1 mm. In actual practice, industrially, if you will see, for every 10 mm there is a reduction of 1. Means throughout the length of 100 mm there is a reduction. For every 10 mm there is a reduction of 1 mm. For throughout the length of 100 mm there is a reduction of 10 mm. As of now, we are dealing with very small components. No need to go up to 10 mm. Try to decrease by 1 mm, is enough. For example, if this distance is 20 mm, try to take here it as 19 mm. Okay, and join one and both the corners. Okay, and place a fillet over, above and below. Okay, here this end is completely vertical and this end is maintaining some inclination. We are not bothered about the inclination. we only see the width, above width and bottom width. There is a reduction of 1:100. Okay, this is sleeve, this is cotter. Okay, these are two shafts need to be butted together to take tensile forces. Before butting both the things, we need to plan a profile of this kind, which is maintaining D as well as 1.3D, which is integral part. Okay, 2 quarters quantity going to be 2, sleeve quantity going to be 1, shafts 2 is the quantity. Fine. Now we'll see the arrangement, how to draw the arrangement. We'll see front and top view of this particular component. Now sleeve, when I view from the front, how does it look like? I could see a rectangle. For example, if this is the front view, I could see a rectangular box of 8D by 2.5D. Same thing I am going to draw, 8D by 2.5D. Okay. Now initially what I try to do is, I'll try to draw one axis line. Okay. Now I'll make a mark of 8D. Maybe from here, this point it is 8D. Again, diameter of 2.5 from here to 2.5 by 2. I'll close the box. Okay. I'm drawing everything from the beginning till the end with 2H pencil only. Okay. I'm going to draw everything with 2H pencil. Later on, once you finish off, you can go with HB pencil. Whichever required, you can darken. Okay. Internally, there is a hole of 1.3D. So from here 1.3D by 2, I'll make a mark. It is, as it is a centrally drilled hole, I need to make it invisible because the material is coming in between the observer and the component. This is 8D, 2.5D, 1.3D. Till here it is okay. Okay. Now I'll consider this as 1, another one, maybe both are of same dimensions. This is of quantity 2. What I take, I'll insert one from left, one from right. Both will come and meet exactly at 4D at this particular point. Okay. Then what happens, rest of the component will come out. Okay. After the sleeve, what is the portion, which is the portion coming out of the sleeve is 0.4D. Okay. Here it is 0.4D. In this area you could see. So maintain that 0.4, extend up to 0.4. Then after this 0.4, make a mark of D, come down. Okay. Draw D. Now the length of D is based on your convenience. It all depends on your convenience. Okay. Till here we'll calculate. Similarly to the other side also. Okay. This width is 0.4D. This is D, which is already given in the question. D will be given, nothing else will be given to you. You need to remember everything, all the dimensions or specifications. You need to remember. Okay. Now this is inserted from right. This shaft is inserted from left. Let us name it as shaft number 1, shaft number 2 for your understanding. Never place this 1, 2 on your drawing sheet when you are in an examination. Okay. One from right, one from left. Afterwards, you need to place a cotter. Where to place the cotter when you don't have any slot? When I view the cotter from the top, this particular cotter from the top, I could see the top view is something like this, which is having a width of 0.3D, a width of 1.3D and a thickness of 0.3D. 1.3D and 0.3D. Okay. This slot I need to drill from top to bottom. Okay. From top to bottom I need to drill that particular slot. So where exactly you need to start? At a distance of 1.3D. For example, from here, from this extreme end point, I need to measure a distance of 1.3D. Okay. Then I'll drop a locus. I'll drop one axis line, something like this. Similarly, from this to the other side also, right side also, I'll measure this 1.3D, then I'll drop a line. Okay. Now I need to drill a hole of or a slot of 1.3D by 0.3D. Okay, from top to bottom. Fine. Let us imagine after calculating you'll get a value, split it into 2 halves. Make a mark of those 2 halves. This is 1, this is 2. Okay. Now the outside marking will maintain vertical. This will maintain some taper section. Similarly, outside will maintain verticality. This will maintain a taper section of 1 mm. Okay. There is a reduction throughout the length. If this is 1.3D, this is going to be 1.3D minus 1. Okay. These are the 2 slots. When I take a cotter, when I insert from top to bottom, what happens? Some portion will remain out, some portion will come outside, bottom side, some will remain top side. Okay, how much will remain top, how much will go down. Okay, try to place the cotter symmetrically with respect to horizontal. As it is maintaining 4D height, from the center 2D above, 2D below, to be on the safe side. Okay, from here I'll make a mark of 2D, so whichever is coming out I'll darken it, close it. Okay, similarly this one also close, the portion which is coming out, darken it. Okay, now overall height is 4D, from the center till this point it is 2D, from the center till this point it is 2D. Okay, I'm splitting the 4D value into two halves. Then again place the curve need to be placed with the help of compass, not with free hand. How to place the curve? For example, there is a quarter of this kind, try to make a midpoint. Okay, now don't consider this intersection, take a value below that, somewhere away, take this as center, from here to this point as radius, draw the curve, then only you'll get a flat curve. If not, if you consider this, you'll get a curve of this kind, which is wrong, this is right. Okay, simple thing to understand. Fine. Now I have inserted one quarter to the left, one to the right, which will lock both the components or both the shafts with the help of this particular sleeve. That is the reason we are calling it as Cotter joint with sleeve arrangement. Okay, this is how we'll draw. So when you draw this, what happens? You will get few clearances. You have to maintain clearance. Now the clearance is going to be 0.1D here. Okay, now both the taper sections, as I said, one side you have a taper section, both the taper sections should face each other. You should not draw the taper section to the other side. These two should face each other. So here also the clearance is going to be 0.1. Okay, because there is a taper section, obviously it is going to maintain some clearance. Here also you find such clearance, which is 0.1D. Okay, this width is 1.3D. Okay, overall length is 8D. Thus major dimensions are very much important to place. Now as it is a circular object which is having circumference, this width again is equal to top view width. Now straight away I'll move on to top view a bit faster. Have a look. I'll take a projector line. Now that length is equal to this length. This width, sleeve width is equal to this width. Close the box. Take a center line. Okay. Again same arrangement. The outer arrangements are similar. 1.3D marking from here. 1.3D and a D. Same alignment need to be followed. Okay. Same arrangement I am going to set. Similar kind. Now when I view from the top, I can't see the complete length of quarter is not visible from the top. Only thing what is visible from the top is I could see this profile which is maintaining some width of 1.3D and a thickness of 0.3D. Same thing I am going to place here by extending the center line, or else you can make a mark, simple marking. Okay, I'll divide the 1.3 into two halves and I'll maintain thickness of 0.3. I'll close something like this. Okay, this is very clear. When I view from the top, quarter will look something like this. Fine. Now here centrally there is a small arrangement. Whenever you meet or mate two shafts, something like this, you are not supposed to touch both the circles completely. There should be chamfer section maintained. Okay, at meeting point, shaft 1, shaft 2. There should be a taper section maintained or a chamfer section maintained. Okay, which will maintain an angle of 45 degrees inclination. Same thing need to be followed here also. With a gap of 0.1 mm, I'll try to draw invisible lines on both sides. Okay, with an inclination of 45 degrees, align your drafter to 45 degrees inclination and adjust with this particular point 45, 45. That is the arrangement you could make. Okay, now try to place most of the dimensions. Okay, not all. Okay, try to make most of them. For example, this is maintaining thickness of 1.3D and it is maintaining overall height of 4D, a diameter of D and a gap in between these two, the gap of 0.4D. Okay, and again overall length from here to, and again there is a width of 0.3D. Okay, thickness of 0.3D and a width of 1.3D, which is already shown here. No need to give over dimensioning also. Okay, and again the corners you need to make a freehand fillet, because we'll eliminate the sharp corners in mechanical. If you'll see in all the components, we'll try to eliminate the sharp corners to avoid the frictional losses in a component. Okay, now finally what I try to do is I'll try to darken the required portion. Okay, sleeve, this is sleeve. Okay, this is a sleeve which is 8D. This is also sleeve 8D. Okay, and there are two shafts on either sides. Okay, this is a shaft number 1, this is shaft number 2. Okay, similarly the front view also, shaft number 1 and 2 need to be darkened, which is visible completely from the front. Okay, which is maintaining a width of 0.4D. Now quarters again. Quarter top end is visible, I'll make it dark. Bottom is visible, I'll make it dark. Curves also, I'll make them dark. Similarly this curve, this end. Okay, I need to darken. And the portion which is completely inside is not visible, I'll make it invisible. This is straight line, this is inclined line. Okay, and the shaft is completely inserted, so it is not visible. Fine, this is visible from the top. Okay, and further they may give you, and again shaft, I could place the shaft something like this centrally. Here it is meeting. Okay, this is the arrangement. If there is a sectional view again, that need to be done. Okay, as you know how to section them all. If I do it now, everything becomes so clumsy. That is the reason I'm not making it. This is the arrangement. Front view of Cotter joint with sleeve, top view of Cotter joint with sleeve. Okay, here you could see this is sleeve. Okay, and this is Cotter. Fine. This is the arrangement which will take tensile forces. This shaft try to move towards right, and this shaft try to move towards left. T1, T2 forces acting. If both the forces are equal, then functioning will be proper. If something is more, something is less, then there will be a collapse in the system. So that we need to calculate. Calculation is not related to this particular subject, only we are trying to represent it. Okay, if it is a sectional view, we'll cut it from top to bottom. For example, here we'll cut it here. So one portion will be remained, only one portion will remain. That remained portion we need to hatch with different cross lines, 45 degrees inclination and 60 degrees inclinations, depends on part to part. Okay, for example, we made a sectional view from top to bottom, or a quarter section we have removed. If it is a half sectional view, only above the axis line need to be hatched. If it is a full section, above and below need to be hatched. Okay, I do some half sectional view, only quarter portion got removed. For example, I'll try to draw side view of this particular component. Side view of this component, roughly the side view going to be, there will be a D visible, 1.3D visible, 2.5D visible. Then again I could see quarter from top to bottom. I could see a quarter, right? So from here there is a quarter placed. Similarly bottom side also quarter placed. Okay, and invisible. This is about the side view. Okay, fine. For example, if the center line, this is one more center line. There are 4 quadrants, 1, 2, 3, 4 quadrants, out of which if I remove one particular quadrant, if I remove one quarter portion, okay, if I align towards the observer, for example, if I remove this portion, if I orient normal to the observer, then only 1/2 will get hatched. Which is that 1/2 going to get hatched? Sleeve, for example, this half, 1, 2, 45 degrees in alignment with an offset of 2 mm. This is sleeve. But here in this case, shaft is also cutted, but shaft should not get hatched. Like shaft, rivets, studs, nuts, like fasteners should never get hatched if they are cutted also. If they are sectioned also, they should not get hatched. Okay, that is the condition. Fine. Now this is about the quarter arrangement, quarter joint with sleeve, which is very much important in the examination point of view, which they may ask you in part A of machine drawing. Okay, if you find any difficulty, you can comment and subscribe. Thank you so much.